All right, so today we're going to build off of some stuff we did last class. However, a little more difficult. So today we're going to talk about graphing linear inequalities. Let's do this first. So when we're graphing linear inequalities, similar to using an open dot and a closed dot, when we're graphing just one variable inequalities, okay, we need to represent them differently on the line. So if it is just less than or greater than, okay, we're going to use a dashed line. If it is less than or equal to or greater than or equal to, we're going to use a solid line. All right, so we're going to start with something fairly simple here. Graphing y is greater than or equal to 2x minus 1. All right, so all we're really going to do is start it just like if we were going to normally graph a line. Okay, and then so in this case, we start with our y-intercept of -1. We have our slope of 2, so we're going up 2 over 1. Okay. And then the only other thing we need to consider is, am I using a solid line or a dashed line? Since it's greater than or equal to, I'm going to use a solid line like so. Okay. So the last thing we need to do is figure out, okay, which side we should be shading on. Okay. There's a couple different ways to go about it. Okay. I'll show you the more precise one is pick a point on either side of the line and plug it into the equation. So let's say I pick this point right here, right? 1, 2, 3, 0. If true, that side is shaded. If false, that side is not. All right, so I end up with 0 is greater than or equal to 6 minus 1. And then I end up with 0 is greater than or equal to 5. Which is obviously not true. False, so 3, 0 is on the non-shaded side. So if that's not shaded, it means this side should be shaded. So what that means is all of the points in the shaded region would give you a true statement for that inequality. A kind of non-perfect way would be if you have y is greater than or greater than equal to. Okay, one way to think of it is you're shading above. If it's less than or equal to, you shade below the line. Okay, which is kind of tough because the more vertical a line gets, it's tougher to tell what's above and what's below. Okay, so it always kind of makes sense to test a point to get the exact answer. Okay, but you can also kind of think of it as shading above or shading below. So again, we get y is greater than. Okay, so you can see that this is, I mean, it's kind of above the line, right? It is, it isn't. It's hard to kind of tell a little bit, but one way to think of it. Okay, we can take a look at another example here. Y is less than negative 1/3 x minus 4. We start with our y-intercept, in this case, negative 4. I have a slope of negative 1/3, meaning we go up 1 to the left 3, down 1 to the right 3. Now, since its y is less than and not less than or equal to, okay, we have to make sure we're using a dashed line like so. Okay, just looking at the graph, this one's a lot easier to tell which side is above and which side's below, right? So y is less than should be shading below. like so. Okay. And again, you can always test a point. 0, 0 is always a good one to test. I'm just going to pick a random one over here, though, in the shaded region, okay, to make sure that when I plug it in, I get a true statement. So this is negative 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So I plugged in negative 5, negative 6. Okay. When I plug it in, it should give me a true statement because that point falls in the shaded region. So I immediately regret the numbers I picked, but that's okay. We'll make it work. So I get negative 6 is less than or equal to, oops, not or equal to, just less than. Negative 1/3 times negative 5 minus 4. Okay, so then this would become positive 5/3 minus 4. I'm going to multiply the whole thing by 3 so I can get rid of the fraction. So I end up with negative 18 is less than or equal to negative 7, which is true. So that point should be in the shaded region, which it is. Alrighty, gonna have some here for you to try out on your own. See where that gets us. Alrighty, so try these 3 on your own. Give you a few minutes. All right, so take a look at mine here. Okay, first one, start with the y-intercept of negative 1. Okay, then a slope of negative 1/3. So you can go down 1, right 3, or up 1, left 3. Okay, and since we are saying it is greater than, it's a dashed line, and we're shading above. Okay, y is now on the second one less than or equal to 4x plus 2. So I start at plus 2, go up 4 to the right one, down 4 to the left one. Okay, it's a solid line. Okay, and these are the ones that, you know, are kind of tough to gauge above and below because it's fairly vertical. Okay, but since it's below, you should be kind of shading to the right because it does slant towards the right just a hair. Third one, y is less than or equal to 5/2 x plus 3. Okay, a little pretty similar looking graph, but we start at our y-intercept of 3. Okay, go up 5 over 2, down 5 to the left 2. Solid line once again. Okay, and should be shading to the right. Okay, questions on that before we make it a little bit more complicated. All righty, so let's talk about systems of linear inequalities. So systems of linear inequalities, essentially all we're doing is graphing two linear inequalities on the same graph, and we're looking for where they overlap. All right, so kind of just going to graph one at a time here. So we start with the first one, y-intercept of 2, y-intercept of 1, and slope of 2. Since it's greater than, we're just going to use a dashed line, like so. Okay, and again, shading above this line. The only difference now, we just kind of want to lightly shade for now. Okay, just kind of give us an idea of what side we should be on. When we go to graph the second one, start at -2. Okay, slope of -1/3. So we go up 1 to the left 3 or down 1 to the right 3. Okay, we're going to use a solid line since it's less than or equal to. Okay, and since it's less than, we want to shade below, but we kind of want to do the same thing where we shade lightly just to give us an idea. Okay, because what we're really looking for is where do they overlap? Okay, and in this case, that would be in that region there. So every point in that region is a solution to both inequalities. Okay, and that's really what we're looking for. We're looking for points that will make both of these inequalities true. Okay. Another important note. Okay. Points that fall on dashed lines are not solutions. Points that fall on the solid lines are solutions. Okay. So let's say, for example, you are asked if a specific point was a solution. I'm going to go, let's see, 1, 2, 3, 4, 5, 6. I'm going to pick -6, 0. Okay. Because that's technically on the solid line. So you might get asked something like this, where is a specific point part of the solution? Well, we'd have to plug it into each one. Plug it into the first one and you get 0 is greater than 2 times -6 plus 1. Plug it into the other one, you get 0 is less than or equal to -1/3 times -6 minus 2. Oh, shit. Shoot. Sorry. Come on, Birdie. Find your way out. Nope, a little lower. Little bit lower. Oh, gosh. This could be a disaster. Oh, so close. Come on, buddy. You can do it. This is, well, that's one way to go. A bird has flown into the room. All right. All righty. Bird's gone. We're back. 2 times -6 is -12 plus 1. So we get 0 is greater than -11. So that checks out. -1/3 times -6 is a +2. So on the second one, we end up with 2 is -2. And so we end up with this: 0 is less than or equal to 0. Okay, is that a true statement? Yeah, right? Because it is less than or equal to. So that makes it true. So think back, if this said y is less than -1/3 x, and this was a dashed line, okay, and then this was obviously just say y is less than 0. I'm sorry, 0 is less than 0. Would that be true? No, 0 is not less than 0. It's the same. So if this was a dashed line, that point would not work. However, since it's a solid line, we are including that point. So we're good there. Let me show you another one before I have you try one on your own. All right, so y is greater than or equal to x plus 1. Fairly simple here. Okay, going to be a solid line. Okay, and since it's greater than x plus 1, we're shading above. Trying to shade a little light. It's obviously probably easier with a pencil. Okay, but shade lightly just so you kind of know where you're at. Second one, y is less than or equal to negative 3x minus 2. So I start with my y-intercept of negative 2. Okay, then I have a slope of negative 3. So I go up 3 to the left one or down 3 to the right one. Okay, it's going to be a solid line again. All right. So now I have less than or equal to negative 3x minus 2. So that should be shading below, which isn't super easy to tell, but it should be over here. So now I just want to go back and darken wherever they overlap, like so. So again, any point in that double shaded region is going to be a solution. All right, you're going to have you try one on your own here. Let's see how we're doing. Okay, so y is greater than 2x minus 3, and y is less than or equal to negative 1/2 x minus 1. A lot of people struggling with just kind of graphing low lines, which obviously would be an issue. Okay, I think for the most part, the shading looked good. Just got to make sure we remember how to graph lines, how slopes work, things like that. So we'll practice more when we come back from break.